to know that Atlas is a helpful robot, not a person.
Seeing Atlas live in action for the first time is wildly exciting. But seeing it perform real industrial work is even more compelling. We recently took this robot.
For most of modern history, global power followed energy. Coal-powered empires, oil-powered superpowers, control energy and industries would follow. That pattern shaped geopolitics for generations. Wars influenced shipping routes. Alliances protected supply access. Economies expanded around fuel stability. The logic seemed permanent. But the world changed quietly. Today, another group of resources is becoming increasingly important. Rare earth minerals. Most people rarely notice them. They are small, hidden, and technically complex. Yet modern civilization depends on them constantly. Inside smartphones, inside electric vehicles, inside satellites, inside semiconductors, inside communication systems, inside renewable energy infrastructure. Modern technology looks digital, but its foundation remains physical. Every advanced system still depends on materials, manufacturing, and industrial supply chains. And this is where the geopolitical balance started shifting. Rare earth minerals do not exist only in China. Deposits exist across multiple continents. The difference is not simply access. The difference is infrastructure. Mining is only the first step. Manufacturing ecosystems matter even more. While many advanced economies moved toward finance, services, and software, China continued expanding industrial capacity. Factories multiplied, industrial zones expanded. At first, many countries viewed these industries as low margin and strategically unimportant. Year after year, processing capacity increased. Over time, that industrial foundation became extremely valuable. Not because rare earths suddenly became fashionable, but because modern technology became dependent on them. Electric vehicles accelerated demand. Battery industries expanded rapidly. Renewable energy systems required advanced materials. Semiconductor industries grew more critical. Then artificial intelligence entered the equation. AI data centers require enormous infrastructure. Advanced computing systems require specialized components. High-performance electronics depend on refined supply chains. Suddenly, materials once considered obscure became strategically important. Governments noticed quickly, because dependency creates vulnerability. If critical industries rely too heavily on concentrated supply chains, economic stability becomes fragile. And modern economies are deeply interconnected. A disruption in one sector can affect multiple industries globally. Manufacturing slows, costs rise. Production timelines shift. What once looked like ordinary industrial logistics became geopolitical discussions. Factories became strategic assets. Ports became leverage points. Supply chains became national security concerns. This transformation accelerated during global supply disruptions. For years, many countries prioritized efficiency above everything else. Lower costs, faster production. Global integration. That model created enormous growth. But it also created concentration. Critical industries became dependent on limited production networks. When disruptions appeared, governments realized how exposed modern economies had become. Automotive industries faced delays. Electronics production slowed. Energy projects encountered shortages. Suddenly, industrial resilience mattered again. Not only profitability, not only speed, resilience. Countries began reassessing supply chains aggressively. The United States expanded domestic investment. Europe searched for diversified partnerships. Japan accelerated industrial security programs. India increased manufacturing ambitions. Nations wanted flexibility. Redundancy, stability. Because technological competition was no longer theoretical. It became structural. At the same time, the global economy entered a new phase. Technology stopped being purely commercial. Semiconductors influence economic power. AI systems influence productivity. Communication infrastructure influences national resilience. Even renewable energy systems carry geopolitical implications now. The line between civilian technology and strategic infrastructure became increasingly blurred. This is why industrial policy returned globally. Governments once believed markets alone would optimize production. Now many governments actively support domestic manufacturing, chip production, battery industries, and resource development. Because strategic autonomy matters more. The ability to produce critical systems internally creates long-term flexibility. And flexibility creates influence. Countries capable of adapting quickly gain enormous advantages during periods of uncertainty. Industrial ecosystems suddenly matter again in ways many analysts did not expect. China understands this transformation deeply. Its long-term investments created industrial momentum difficult to replicate quickly. Manufacturing scale matters. Logistics efficiency matters. Infrastructure density matters. Modern production systems require years to build, coordinate, and optimize. That is why rebuilding industrial capacity elsewhere takes time. Factories cannot appear overnight. Supply chains cannot reorganize instantly. Technical expertise cannot expand immediately. Industrial power grows gradually, and gradual systems often become powerful quietly. This is one reason modern geopolitical competition feels different. It is not only about visible military strength anymore. It is about infrastructure. Production. Energy systems, semiconductors, data centers, advanced materials. The competition moved deeper into the structure of the global economy itself. The next era of global influence may look very different from the last one. The 20th century focused heavily on oil, heavy industry, and military expansion. The 21st century increasingly revolves around technology, automation, artificial intelligence, and industrial resilience. And all of those systems depend on physical supply chains. Even digital power requires real-world infrastructure. Servers require energy. Batteries require materials. AI requires semiconductors. Factories require logistics. Nothing exists independently. That interconnected reality is reshaping global strategy. Countries are now competing not only for markets, but for technological endurance. Who can sustain production? Who can adapt infrastructure? Who can secure critical materials? Who can maintain industrial stability during disruption? These questions increasingly define modern power. This does not mean conflict is inevitable. Global economies remain deeply connected. Trade continues, partnerships continue. Technology still moves internationally, but competition intensified. Nations now view supply chains differently, not only as economic systems, but as strategic systems. And rare earth minerals became symbolic of that shift. Small materials, hidden inside modern technology, now influence discussions about energy, industry, security, and long-term geopolitical balance. Most people will never see them directly, yet they help power the systems shaping modern civilization. And in many ways, they reveal the deeper reality of the modern world. Global influence no longer depends only on visible power. It increasingly depends on the invisible systems underneath it.